Okay, in today's lab, what we have is this apparatus. So I'm holding onto this little tube, and it's just a nice slick tube, and I have some very slick fishing line that is inside of the tube, and on one end we have a little rubber stopper that you have the mass of, and at the other end I have a paper clip from which I have hung a mass. And so this mass is pulling down, and the rubber stopper is on the other end of it, and so of course this would just fall down if I let go of it. So I have a couple marks that are made on it. There's a little black mark right here that when it's right here, this is 1/2 meter in diameter, and there's another black mark that's here, so it makes it a whole 1 meter diameter. And so that was our setup for today. But what we're doing here is I am spinning this thing around, and as I'm spinning this thing around, of course, it needs a certain amount of centripetal force pulling in on it. Now the weight of this is pulling down, so if the weight of this is bigger than the centripetal force that I need here, what's going to happen is this is going to go down because this is bigger than that one is. If I start spinning it too fast, then I need more centripetal force than what this weight is providing, and so it goes up. So if I'm at a spot where the little black mark stays in the same spot, if I can keep that staying in the same spot, then I know I'm pretty much in balance between the amount of centripetal force that this needs and the amount of weight that this is providing. And so the weight and the centripetal force should be in equilibrium when that little black mark stays right there. If I need to bring it out to here, I need to change that, and so out here we went for a different amount. And so again, I have to find that equilibrium speed that keeps that moving at the same speed, at the same spot. So if I'm not going fast enough, then you see that mark going down. If I'm going too fast, it goes up. And so what we did was we just timed how long it takes to go around 10 times. So our start-stop error is a little lower. But I just wanted to show you the apparatus, so you're going to see the data table, and you're going to see it filled out, but this is what we were doing when we were filling up the data table. And of course, if I change the mass here, then I'm going to have to change the speed at which this thing spins, because again, the speed of this thing has to be in balance with the weight here. So if I put a heavier weight on here, I'm going to have to spin faster to counterbalance that. If I have a lighter weight on it, then I'd have to go more slowly to balance it out.